So, on our last episode, we got to some actual programming. And we got some stuff done in our game. So if we hit play right now, we've got the ability to move left and right, and we've kind of got some gameplay in here. There's obstacles that come in from the background. They actually scale in as opposed to just popping in. And when they arrive at your cube, they can destroy you. Bam! I'm dead. We can move infinitely in the lateral directions. We can move infinitely in the forward directions because we are actually not moving at all. The world's coming to us. It's actually kind of... Oh, we have the offsets wrong slightly on these because they're evidently going through the ground. Wait, I thought we had that set up differently. So that they would scale from the bottom? Huh. Evidently we have a bug. Sweet. Bugs happen. So let's see what actually is going on with that. So we've got Pillar Parent here. And if we put one of these on the ground and scale it up... it scales from the bottom, so that looks right. But, for some reason, when we were actually spawning these things, they looked like they were still scaling from the middle. Do we still have scale over time on here? No, we do not. Weird. Alright, let's take a look at this thing. I'm going to delete this. I'm going to make sure that our pillar spawner is actually spawning pillar parents. It is. I'm going to double check our pillar parent in here just to make sure that we've got everything set the way we think we do. Looks like we do. So that's it's a little weird that they're coming in differently. So if I go to the scene view, let's see what we're doing here. Yeah, they're scaling in from the center. Huh. What's the deal with that? Alright, so let's see what they're doing. So if I go into one of these, let's pause the game. We can pause it while it's going. And let's take a look at one of these guys to see what's going on here. So it's not got a Y offset for some reason. Huh. That's weird. Okay, so I am noticing some problems. So first of all, we're doing move left and right on the child and not the parent. So that's something we should probably change. We're also only destroying the children, it looks like. So that's, and that sounds horrible, destroying the children. But that is indeed what we were doing here. So we're going to want to switch some of these scripts over to a higher level at the very least. So let's fix that, because we can see that problem. And then let's see if that solves any of our other problems. So we're going to copy this component, and then remove it. We're going to go over to the parent and add it there. Whoops, that's the help thing. Click that, you'll get little helpful tips on how to use a component. Paste component is new. I wonder what it does for... Okay, yeah, if it's your own component, it just goes to mono behavior. So, pillar, we're going to grab move left and right, and we're going to copy component. We're going to remove component, and again, we're going to go to the parent and paste component as new. And we're going to grab destroy under Z value. We're going to copy component, remove component, and paste component as new. The collision stuff being in here is probably appropriate, so I'm going to leave that in there. And we shouldn't have to use gravity on it, even though it does not matter because we're setting is kinematic here. So I'm going to hit apply, so this all goes to our prefab. And I'm going to delete it and see what we get as a result now. So... oh, now it's looking good. Yeah, that was our problem. So I think what was happening is either the move left and right script... Here, let's look at what's going on here. So one of these scripts, I think, caused it to change where it was at in a way that I wasn't really expecting. Let's just see. Because we had a position information on it before, and it seems like it just ignored it. So... that's not at all what I opened up. I wanted to move left and right. So this is modifying the transform position, so it shouldn't have been a problem here. It's fixed now, so maybe I shouldn't care that much, but I do like to know why things break. But we fixed other problems that we saw, and hopefully, I mean, it looks like it fixed our problem, so... scale over time. Does this make any assumptions about position? Nope. Doesn't look like it. Yeah. Oh well. No harm done, I guess. Good, we are on my screen. Just was double checking. I get worried that you're just staring at my face while I like scratch my nose and fix problems on the game, and you're not seeing any of the stuff I'm actually talking about. So that's cool. This is all working. Now, it still kind of feels like they're floating when they're on the edges, and it's because they are. If we hit pause, you can see that we can see beyond that. So let's actually make our ground a little bit bigger. And what we're going to do is, let's make it 1,000 by 1,000. And we have to multiply everything else by 10 to make things work the way that they were working before. So I'm going to make the tiling 100 by 100. I'm going to change where the pillar spawner is. I'm going to put it out at... no, we can leave it out there, I guess. 1,000 by 1,000 is probably more than we needed. Whatever, it doesn't matter. Let's move the protagonist and the main camera back. So he's at 45 and 50, and so they should be at probably 500 and 495. So if we hit play now, we got things way further away from us naturally, so let's fix that. Let's make those things come in a little bit closer. So we're going to go to our pillar spawner, and we're going to move it. Let's move it to negative 250 and see how this works. Oh, and we made an assumption. We forgot that the pillars themselves destroy themselves at a certain Z value, and I've modified these Z values now because of moving things around. So if we go to the pillar parent, destroy under Z value, we want this to be at negative 500 now. And we probably also want to change the speed at which we're traveling so that things line up properly. Although that looks like that already is working. Interesting. These guys still are coming in from a long ways away, so I might want to change that again, because otherwise it'll be boring for testing. So let's just move the pillar spawner way closer. Let's move it to as close as it was before, which is at would be at 450, I think. Actually, we're probably at 400. Let's see if that looks kind of like it did before. Yeah, it does, but now it looks like they're coming out of the ground, so I'm actually going to move them back a little bit. 300. Still kind of looks like they're coming out of the ground, but I'm just going to work with it. We can tweak this stuff as we go. So, that's awesome. I'm kind of thinking I kind of want to put the player more towards 0 and just move everything else forward just so that we know where the back of the level is. I'm going to do that right now, even though I'm going to have to reorganize things a little bit again. So we're going to move hero protagonist over to 0. Actually, let's just let's create an empty game object. We're going to let's put it right where not the main camera, but where hero protagonist is, which it already is. Sweet. And let's just grab all these things, put it down here, and move it forward to 0, and then grab all these things and pull them out again. We'll delete our temporary game object that we used to move things around. So now we're here. We're gonna have to change where the pillars delete themselves. Honestly, if they're deleting themselves sometime behind us, it doesn't really matter that much. But let's be good about this and actually delete them as they go to the right place. So we're gonna go to our pillar parent, and we're gonna set that to we're gonna destroy them at -5. So that's right where the main camera is, I think. Yep. So sweet, we should have things working. Where are actually the pillar spawner now? 195. Yeah, let's put it at 250 even. Not really. Well, I mean, it is an even number, but yeah. All right, cool. That's still going to take forever to get to us, so for testing purposes, never mind. I'm just going to deal with the fact that it doesn't look right, and we're just going to leave it at 100 so that we can actually get to gameplay faster. We also could probably pre-populate some pillars to start with, and actually that might make a good sense. That way we can like have some, kind of a ramping tutorial where it shows you kind of how to play the game, and then the actual spawning starts later. But yeah, so we have pillars, they're spawning, we can move, and they keep spawning, and once they spawn, they stay there. We're not actually physically moving in the scene, remember, so that's nice. We could actually probably make them spawn a little bit wider again. And also, we could make these pillars a little bit thicker, too. Let's actually do that. Let's go ahead and scale the pillar out a little bit. So 2 and 2. See how that looks. Yeah, that's a little bit more threatening. They're now twice as wide as the cube is, or at least in theory they are, which actually doesn't look like in practice they are. Wait, no, they are. Maybe. Yeah, those are big. So we got big pillars now. Alright, cool. So we have our basic gameplay here. We've got it cleaned up a little bit. I'm going to go ahead and just submit this into our Git repo using source tree. We're going to... that's a weird thing to... Oh, yeah, that was the tiling stuff. So we're going to move all of these, and we're going to say tweaking the gameplay / look a bit. Also fixing scaling bug. All right. So, what to do next? Let's work a little bit on game over condition. Let's actually make it so that when we die, we stay dead, and we can reset the level by hitting a button at that point. So, what are we going to do here? We're going to create a new script. Create a C# script. And we're going to call this... I'm going to call it Game Manager. We're going to make it nice. I'm going to, call it Game Manager. Actually, I wanted to put a $sign in the front of it, but I realized that it doesn't sort by alphabet, and I haven't put that script in that makes it sort by alphabet here again. We probably will at some point, just because that's a useful script to have. So our Game Manager is going to handle all aspects of our game. And so this is probably going to handle score, it's going to handle, like, game state. If there's power-ups, we'll have power-ups. Well, we might not have power-ups in here, that might be elsewhere. But for right now, it's primarily going to detect when a game over condition happens. If we have lives, it'll probably handle that stuff too. So right now, all we want to do is have a game over condition. And I'm going to use a debug function at first to do this. It's actually technically not a debug function. Unity has a built-in GUI system, and it's a good system for rapid prototyping, but it's not a particularly good system for actually making a GUI. So this is really good for just getting debug information on the screen. So what I'm going to do is onGUI is another special function that's in mono behaviors, and this function, when it's called, draws GUI elements. What we're going to be drawing is just text that says game over if we're dead. So what we're going to do is onGUI. So I'm going to have a private bool. This is a Boolean value. We haven't used these before, but it basically just means it can be true or false. So private bool, we're going to call this game over. We're going to say it's false to start with. And on GUI, we're going to say if game over equals true. That means if... Why does it do that? I hate that. Game over equals true. So if it equals true, we're going to display game over. And the way we're going to do that is we're going to use GUI layout, because I'm lazy, dot label, and we're going to just say game over. Press any key to reset. We will be doing more than just this later. We'll have like a menu and different things like that. So, but this is our temporary stuff for now, so we can get things rolling. So, game over, press any key to reset. And what we're going to do is in our update here, we're going to say, so how do we determine that our game's over? So right now, I'm going to go to our hero protagonist, and we're going to give him the tag of player. It's a bunch of built-in tags, and then you can also create as many of your own tags as you want. But we're not going to worry about that because we already have a tag that we want. It's called player. So what's the best way to check this? So all we're going to do is if game object dot find game object with tag player. I hate that phone. Apologies about the phone. Thank you, Unity. Thank you, MonoDevelop. I'm going to have to figure out where that's changed and change it on this show so that people know and can fix it. I just do not like this layout at all. They keep making it worse with every version too, I swear. So find game object with tag player. So this actually isn't going to work because find game object with tag player will return something that's an object, or will return null. So you have to check to see if it's equal to null. So if we don't find the player on a frame, we assume that he's dead, and at this point we call game over. That's all we're going to do for right now. We may change this later if we add lives. It may not require a find game object with tag call later. This is just temporary for now. So what we're going to do is game over equals true. And then we're going to say if game over like the bottom line doesn't even make sense what they do to it. Whatever. Constantly fighting the tools now. If game over, we are going to make it so that if input dot get any or get key any there we go any key down, input dot get any key down, or just dot any key down, then we are going to reset the level. And the way we're going to do that is we're going to do application dot load level, and we're going to feed it the loaded application dot loaded level. So in theory, this should reset the currently playing level. So we're going to hit play, and we're going to realize that we didn't attach the script to anything, so it's not going to do anything. So we're going to create a new game object just for our gameplay manager. We're going to call this game manager. And we're going to put game manager in it. I'm going to drag it to the top so it shows up at the top. And this doesn't have any options, so theoretically this should just work. So if we hit play, now we may have a slight load time when we first die because Unity's initializing the GUI system for the first time. So we'll see what actually happens here. So if I die, bam, game over. And if I press anything, it resets. So right now, the game over screen actually, so that all worked, yay. So we're going to die, it says game over, press any key to reset. It just keeps sending stuff through the world. That's fine. And yeah, so we have a basic game over condition and a basic reset condition. So now we can play forever without having to, bother with hitting pause on the game editor and hitting play again. So that we actually are one step closer to a legitimate game. So that's great. we're a lot of steps away from a legitimate game still, and we want to make this thing look prettier and work a lot better and add a bunch of features and stuff, but there is something here that you could call a game at this point. So I'm going to save scene, save project. I'm going to say it's a game. We're going to push these to the origin. And I'm going to go ahead and see if we've got any viewers that have sent us any comments yet. So, view all comments. Alright, if this has 30 parts, I wonder how the final product will be like. Will we even reach the 30 parts? We may not. Really enjoy the series so far. Thank you very much, appreciate that. We'll learn how to optimize in these tutorials, like for material, draw call, and other factors in this series. Yes, though admittedly, the game that we're going to be making, you probably won't have to optimize anything for it to actually not have a problem on any hardware. This is a pretty simple game project as far as things go. I will point out places where that we can optimize, especially on draw calls and on material sharing stuff. But as I said, this is not going to be a heavy game. Pillars should get wider when you get farther. This is an idea for more gameplay. Yeah, actually, that's a great idea. We can totally change that. And Cologne is solving my problem in monodevelop. Preferences, source code to code format, C# source code. This should let you change how monodevelop auto formats code. So let's look at that. Why not? Preferences, source code, code formatting, C# source code. Formatting. Wait, is preferences? Oh, source code. Preferences, source code, C#, no, code formatting. Is this it? C# source code. There we go. Alright, C# format. Alright, edit. Oh yeah, it's one of these fun things. So, declarations within namespaces. That looks good. Sure. Yeah, I don't have a problem with any of those. Wait, so what does this change? Oh, property. Okay, this is indentation, so I don't really care much about the indentation statements. What does this do? Okay, so this is all indentation. I don't care. Actually, switch body. I want to probably change this one. So how does switch body look? Yeah, I definitely want it to indent inside of switches. So braces. There we go. Namespace declaration, next line. Anonymous methods, next line. Statements, next line. I basically always want next line. Next line. Next line. Next line. Let's start with this, and then I'll not bother changing other stuff until we brace enforcement. Oh, add them. Definitely. The reason for this, I think it's incredibly bad practice to not have. Seems to have already had them. So I think it's bad practice to not have these brackets. You can make an if statement that's a single line, like this, like it shows here. If true, console write line, and it is a little bit shorter, and it might even be easier to read. The problem with it is if you decide to add another line underneath it, it's very common to make a mistake where you add a line and you forget that it's only actually checking if on the first line. So like if there was another line underneath that says console write line something else, it'll write that no matter what, and it looks like it's under the if statement, but it's not. So let's add braces. And spacing. I do want some space. White space. I want to 4 opening parentheses. No, I like that. I like that there. After comma in parentheses. Sure, I can get behind that. Sure. No. For opening bracket. I don't even know what that format is. I've never even seen that formatting before. Yeah, get rid of that. And before opening parentheses, I'm just going to get anything that says before opening parentheses. I'm going to assume that it will anger me. Man, there's so many. Yeah. Alright. Looks good. Alright. I'm going to hit OK. We're going to call it good. Okay, so now I will have to fight it less, hopefully. Still probably will have to fight the initial settings for the classes, because that's actually generated by Unity and not by this. There's templates that I can change. Actually, someone pointed me to them, but I haven't had time to check it out, and I'm not going to burn more time on that on the show. So let's hit play. And what do we got going on? So we've got a game over condition. We got a reset game condition. Let's put a score in. Games need scores, right? And so we're going to do it in a debug way as well. I'm going to go ahead and put this into the game manager. We really could have it as a separate score manager. Let's do a separate score manager. Let's go ahead and create a script called... No, I want it in here. We're going to make this a little bit monolithic. Kind of makes sense for a small enough game. So we're going to have score in here. So what we need for that is I'm going to create a... our score in this game is going to be distance. We might have additional elements that improve our score as well, but our initial score is just going to be distance-based. So I'm going to create a public float points per unit, points per unit traveled. That's a big wordy thing there. And I'm going to default it to 1.0f. Remember, that's just defaults. We'll probably change it. I like bigger scores than that, typically. And what else we're going to do? We're going to need to store the information on how far we traveled somewhere. So I'm going to create a private float score. And we're going to... I'm going to say it's defaults to 0.0f. It will automatically do that, but sometimes it's better just to be specific. So private float score, and what we're going to do is on our update, I guess we could do it points over time too. That would be a little bit easier because then we don't have to assume speed. But yeah, let's take a look at it. We're probably going to have speed change in the game manager anyway. So how are we moving things? That's right, everything else is moving. Yeah, the game manager is going to have to handle speed, because what happens here is we're going to be spawning a lot of things, and each of these things right now are using a move script that have a set speed, and we want to eventually have the speed change. And so we're probably going to change the movement here to actually reference the game manager's speed settings. So I'm going to go ahead and do that right now. So we're going to do public float game speed equals 1.0f. And actually I'm going to default that to a proper one, so it's going to be equals 10.0f. Save. And what else are we going to do? So I'm going to go ahead and start plugging this into... I'm kind of jumping away from score here for a moment to organize this stuff. So we're going to create a new movement script. I'm just going to duplicate our move script. Duplicate. That's Command D or Control D if you are on Windows. And we are going to be doing move based on game speed. So, move based on game speed. Move based on game speed. You have to make sure that the class always matches, the class name always matches the file name. Otherwise, Unity will not attach the scripts and be happy with you. And we're going to have to do one more thing. We're going to have some way of accessing the game manager. And so what I'm going to do is I'm going to set this up as a very light singleton. It's actually, this is not really a singleton pattern, what I'm going to be showing you. This is a portion of singleton pattern. I'm going to be creating a variable to hold the instance of the script, and we're going to assume that we only have one of them. And when the script instantiates itself, when the game starts, it's going to be like, I'm the script, and then other things can grab the script from that variable. So what we're going to do here is we're going to do a public game manager. See, this is actually the class that we have. We can make our own instances and references to our own classes like this. So public game manager, I'm going to call it with a lowercase g. If you haven't figured it out by now, because I didn't really actually mention it on this series yet, code is very much capitals matter. And so game manager with capitals does not mean the same thing as game manager with lowercase. And it actually doesn't even mean the same thing as game manager with something like that. I would recommend not doing too much ransom note capitalization because you'll drive yourself crazy. But it can be useful when you want to name something what it is, but without actually overriding the actual reference. And this is part of the reason that I typically recommend classes should be uppercase for every word, and properties and variables should be camel case, where the first word is the first word is not capitalized, and all other letters are of words are capitalized. So game manager. Actually, I'm not gonna call it that. I'm gonna call it game manager instance. And in the start here, all we're gonna do is instance equals this. This is a special keyword that means this script that we're currently in right now, or rather this class that we're currently in right now. So now, and actually we're going to do one more thing. This is going to be a public static game manager instance. We haven't done static variables before, but static means that this exists no matter how many of these game managers we make. There's only one of these. And additionally, it means that it can be accessed. So normally if you want to access like say you have your rigid body dot add force or something. You have rigid body. This is actually an instance of rigid body. The actual class itself, rigid body with the capital, has its own set of functions. And actually, this one doesn't have very many good examples, but Vector 3 has a pretty good examples. Like Vector 3 has like Vector 3 dot and Vector 3 lerp and all these other things. They're built in at the class level. So this means that we can access game manager dot instance from any other class just by doing game manager dot instance, and then we can access that particular instance's variables like points per unit traveled and game speed. So we're going to save this, and we're going to go move based on game speed. We don't need speed anymore here. We do need direction, and what we're going to do is instead of speed here, we're going to use game manager dot instance dot speed, game speed. So if we hit save now, and so we don't have any compiler errors, that's nice. Game manager score is assigned but never used, that's fine, we haven't actually hooked all that stuff up yet. So we're going to do our pillars, because these are currently using the move script. And we may be changing our lateral speed too, but for right now I'm just going to replace the movement speed here. We may not want to change the lateral speed ever, so let's just do it here. So we're going to remove this move script component. We're going to add move based on game speed to our pillar parent. And then we're going to set the direction to -1, because remember, our game speed is a positive integer, and this time we want to actually be moving in the negative z. Z is, you can see this little blue thing points z out. Our camera's pointing z out, which means that negative z is what we want. So if we hit play now, everything should work exactly the same way as it did before, and it does. Except for now, if we go to the game manager, if I pause this or something, because it's hard to catch this thing, and we unpause it, and then we adjust the game speed, these things should start moving faster. And they did. Look how fast they can move. It's crazy. And we can even make them move backwards. Look at it. Bring them all back. Actually, we can't bring the ones back that already killed themselves, but So now we can actually adjust the game speed as things progress, and all the elements, well, most of the elements will the pillars will pay attention to it right now. Obviously, we also are not changing the ground speed. So if we hit play, like say we set the game speed to 1000, you'll notice that the ground is cruising at this nice little short pace while we're being destroyed by pillars that are just coming in incredibly fast, so fast that they haven't even scaled in all the way yet. Which is not what we want. So we need to fix that as well. That being said, I'm going to switch back over to score first, and then we'll fix the ground speed later. So let's go now to our game manager, because now we have our game speed here. And so all we have to do for score is, in our update loop here, we will put in, doesn't actually matter where we put this as long as it's not in one of these if statements. We can put it at the top or the bottom. It just determines when this thing's actually calculated. So all we're going to do is score plus equals points per unit traveled times game speed times time.delta time. There we go. Actually, I don't mind that it added those spaces in for me. I'll live with that. And so now we'll get our score updated. But we're not actually showing the score anywhere. So we also want to put in a on GUI call. So what I'm going to do is I'm going to do a GUI layout dot GUI layout dot label. Actually, I'm going to do this after the game over thing. So we're going to do, no, I'll just do it here. GUI layout label, and instead of putting a string in here with quotes, we're just going to type in score.toString, which means we want to convert score from what it is into a string. And there, it did that thing again. It put a space there, and I thought I got rid of all the spaces on those things. Save. Oh, I just want to see preferences real quick. Code formatting, C# code, C# format. Braces, no. White space. Before opening parentheses. I thought we did this on all of them. Not seeing any. Weird. Whatever. Alright. So, GUI layout.label. We've saved it. Hopefully this will work. Didn't get any compile errors. That's nice. So we hit play, and now we have a score in the upper left corner. It's kind of a weird looking score because it's got a lot of digits that we really probably don't care about. But it is a score nonetheless. So, if we want it to be less digity, we can actually change that in our score formatting, or we could change our score to not be a floating point value. The danger of changing it from a floating point means that we have to deal with subvalues, so I'm not going to actually change that. Or we could assign it to an integer. Let's just do that. We're going to do score.string, and before we do score.string, though, we're going to do put this around here and put int here. So now it should convert score to an integer rather than a float. Nope, I couldn't do it. Can't convert type string to int. So int score dot toString. So I think I did something wrong here. Would have thought that would have worked though. Alright, so I'm just going to create a temporary int current score equals score, and we'll cast it to an int here, and then we will do current score dot toString. Save, play. And now we have it just as a number there. Sweet. So now we have a score. And it's not very well labeled, though, so let's label it real quick. So with strings, you can actually add them together, and it'll concatenate them. So if we type in score, actually, let's do low case. Score, and then plus current score to string, it should now say, and actually I'm going to put a space between it. We're going to play, and it'll say score, and then it has your score there, which is great. So let's make one more thing. Let's do a high score. So the quickest and dirtiest way to do a high score is to use a static variable. We're going to start with that. We are going to replace it later with something else. But for right now, it is easy to implement because static variables do not reset automatically. Like if you create a new version of the object or if you reload a level, static variables will stay where they were. So what we want to do is we're going to create a private float high score. And we're going to default this to 0.0f, and actually we're going to make it a public private static float high score. And we're going to add a little bit of logic here. What we're going to do is if score is greater than high score, then we are going to see, it's doing all the old stuff again. It didn't work. Thanks for trying to fix it. I'm gonna save this. I'm gonna quit MonoDevelop. I'm gonna open MonoDevelop again. Just see if it fixes it after that. Let's just take a look at this. We're gonna open up C#. That'll open up a MonoDevelop file. And let's just give this another shot. I'm just gonna do if score. Well, let's do that, and it did it again. Sweet. All right, so there must be some other magic place that I need to change something somewhere. I'm not going to worry about it for right now. So, if score is greater than high score, what are we doing? We're going to set high score equal to score, and down here we're going to do int high score. Sorry, int current high score equals int high score, and we're going to add one more GUI layout label, and we're going to call it high score. Actually, I'm going to just call it high. High score. And then finally, I noticed a little problem that we've got here. Right now we're adding score no matter what, so if we die, it'll keep adding score. So let's actually wrap this in one more if statement that says, if not game over. An exclamation point at the beginning of a statement means not. If you select a bunch of things and hold Shift and Tab, you'll tab over to the left. You can also just press Tab and you'll tab over to the right. So that's one way you can fix things when they decide to go haywire like this. I swear it's getting more picky than it has ever been. It's just pushy now. MonoDevelop used to be so nice. So nice. Alright. So now we're going to hit play. And so now we have got a score and a high score. And if we die, which I'm going to do right now, right here, the score stops going up, and we have a high score. And if we hit a key, oh, the high score reset. So that's a problem. So let's see what happened here. So I set this as a private static float high score, and it reset. That's weird. I'm going to try a public static float high score just in case. I don't really know why that would make a difference. I just want to see if it does fix it. Or wait, I know it's wrong. Yeah, okay, never mind. That's not the problem at all. So we're gonna keep that private. The problem was I didn't actually change it to use the current high score instead. So it was actually just displaying the score on both lines. So we're gonna hit save. And here we go. We can move left and right. We've got score. We've got high score. And man, we'd be dead. And then we hit a button, and we're going, and we have a high score. And so now we want to see if we can beat our high score. So I'm going to try and dodge some things. And there we go. Our high score is increasing again. And then we die, and game over. And it says high score 148. And if we die before the high score changes over, I just want to test all of the edge cases here. It should still retain it. I don't see why it wouldn't, but yes, it retains the old high score. So we have a high score and a score system. So let's go ahead and save this stuff and put it into our Git repository. We're going to drag it up there, commit, score system, and unified speed system. Push all commits immediately. All right, looking good. I'm liking where we're at on this project so far. So let's see if there's any more comments. I'm just going to refresh this. Thanks for inspiration, dude. You're very welcome. On a strict budget right now, but I'm very close to releasing my first game, in part due to what I've learned from cooking with Unity. If I end up earning anything, I'll be sure to kick some back to Vanguard V. Thanks, Max. Thank you, Wesley. I really appreciate it. You should, if you can, if YouTube will let you, you should share a link to your game, or at some point on an episode if you have it ready at some point. Squid Squad Studios should make a port to Rift as well. Yeah, actually, Justin was talking to me about that. It's actually super easy to do it. Like the Rift SDK is super awesome. I love it. They did everything just right. Like it's one of the easiest things to work. One of the easiest things to work with I've worked with. So that's tabbed over way too far. Let's get back to what we're doing. So we've got a high score. Now, if we quit the game, it doesn't save our high score. So let's actually go ahead and save our high score as well. So we can save this out to player preferences. Player preferences is a magic little save location that is platform dependent. It's platform independent when you use it, but like it will store itself in different places depending on your platform. But it works on all the platforms. And so if you do a player prefs thing, even if you make a web build, it will still save the stuff somewhere on their computer. Actually, web build, I should probably make a caveat. You can only store up to 1 megabyte of data in a player prefs. They do that because they don't want you to just, bloat someone's computer with save data. But 1 megabyte is a lot of data. There's so much we can save in a megabyte. We're not going to be using anywhere near that because most of what we're going to be saving is scores, which is going to take way less than a megabyte. What we're going to do is we're just going to handle the basic cases for it right now. And I'm just going to save out the high score when a game over happens. So I'm going to create a separate function because we haven't done this yet on this little mini-series. You can create a function. You can just type in this, and it's a function, and you can call it later. You shouldn't type in that. You should, type in something useful like save high score. I'm creating this as a function because I know we're going to be calling it in more than one place. So what we're going to do is we're going to do player prefs dot set. I'm going to save them. I'm going to save it as an int. Set int. And we're going to do the same thing here. We're going to do the int current score here. Actually, I don't need to do that here. I need to figure out why it didn't work to just do the int cast before the toString. I probably just had something wrong in the way I put the brackets around things. So set int, and we're going to, it needs a string for the key, so we're going to call this key. So basically when you use player prefs, each thing is stored under a name, this is a string. And so we're going to call this high score. And the value will be our high score as an int. So int high score. And then I'm going to go ahead and explicitly type playerprefs.save. So now, if we save this and hit play, we've got the score going on, we've got the high score going on, and this isn't going to do anything, actually. So we've got the high score, there we go. We stop playing and we play again, and it's reset to 0. And the reason being is we created this function, but we didn't call it anywhere. So we're going to just copy this and paste this into, where do we want this to happen? Let's do it on... So right now, I'm just going to create another variable. We're going to call it private bool has saved. We're going to say it is equal to false. And so if game over, if any key down application load level, we're also going to put a little thing in here. We're going to say if not has saved, we're going to save high score here, and we're going to put a semicolon there and type in what are we doing, has saved equals true. This way we're only saving it once, and it happens the moment that our game is over. So if we hit play, we've got the high score counting up. That's working well. And we've got the score, yay, and we die. And it says game over. And if I stop playing at this point and play again, it didn't work. So, if game over, if not has saved. Oh, yeah, that's right. So we're saving it, but we're not actually getting it. We're not actually loading the save. Forgot about that other really important thing. So I'm going to create another thing here, void load high score. And we're going to use playerprefs dot load get int, and the key will be, what is it called? High score. And what else we're going to do? So we get that int, and get int actually returns it to somewhere. So we're going to say high score equals playerprefs get int high score. That's all we're going to need to do, and load high score should happen at the start after we set our instance. So we're going to do load high score here, and hit save. And so now if we hit play, we should already have a score, actually. Yep, we've got our 103 that was saved before, and now we'll actually properly load that and display it each time. And so now we have a fully functional score system, and we've got gameplay, we've got a game over condition. We're looking pretty hot for this episode. I would say that this went really well. So 191, and now we can stop playing, and we hit play, and we have a score. Yay! So I'd say this is a pretty good wrapping point. We're a little bit early, but I'm just going to call it a wrap because I'd say that this is a good place to stop for right now. So we've got save scores locally. Save high score locally. And we're going to commit. And so that'll send up into our repository. And that would be it. I'm just going to do a quick browse of, here we go, nope, no new comments. So, thank you for joining us tonight. Hope you had a good time. I certainly did. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. And Phil's not here, so I'm not going to say anything about him for right now, but he'll probably be here later. And you guys have a great night.